Hello everyone, I hope you are happy and healthy. Now, we are back with another UPSC CSAT PYQ analysis. Where our aim is to now pick apart each year's question paper. And our aims are, I intend to provide you not just a solution to the questions, but the most efficient way to solve UPSC's CSAT 2023 questions. And apart from this, I would be also edging you to find patterns in the questions. Apart from this, I will give you shortcuts whenever needed to arrive at a solution much more easily. And fourth, sometimes in the options itself you can guess an answer. I would also be providing you that. I call this option analysis. Now, before getting into the thick of the things, let's see what does UPSC expect you, or what does UPSC want from you, especially with CSAT 2023 in mind. 1. UPSC's wants. 1. They want the students to take CSAT seriously. And how serious? Almost at the level of GS. Although one is qualifying in nature, but they want you to give it as seriousness as you give GS. And 2, they are not just interested in your application. There are some questions where you need to apply, but they are much more interested in your thinking. Apart from formulating way to the answer, many of the questions, as we see, we will go through. If you are able to find a pattern, the answer becomes much more easier. Number 3, they want you to find patterns, not just solve a question based on formulas. They want you to see patterns. And 5th and 4th, the importance of basics. If you have gone through rigorously, there are at least 10 questions based on non-conventional topics like general addition rule, general multiplication rule, addition of 2 numbers, carry, multiplication, so on and so forth. Just general basics. And one more trend here is optimization. How can you maximize a number? How can you minimize a number? How can you maximize attempts? Optimization. Or and what do they mean by this? By giving these, UPSC is signaling you that apart from that formula, the standard formulas where you get time, speed and distance and all, they want you to have a keen sense of numbers. And as you might have recently come across now, the topics from number systems have increased previously and questions are very good. So, and how shall we achieve this? By our approach will be 1. We will solve the question based on attack points. Where we analyze a question after seeing a question, instead of rushing in, we'll formulate a path and see where to attack, what will be the most efficient way to reach an answer, and then we will not use any high-fi shortcuts or techniques, basic principles, and focus on basics. And before we start, it is important that you enjoy this process as much as I do, because when you start enjoying a thing, it will be easier for you to find patterns that you can use them in future too. But if you come with a negative attitude or thinking it difficult, the pattern finding becomes difficult. So please, I really enjoyed solving this paper. I hope I will provide you as much enjoyment as I have received. Now let's start with, and even before starting, to make it easy, what I have done is I will deal all the topics, all the questions that concern a specific topic at once. Suppose we will start with number systems and we will go through whatever number system questions are there, and then so that searching reference becomes easier and revision too becomes easier. Now let's start with quants first and see number systems. Let me just see what questions start with number systems. Yes, question number 7 is number systems. Clean. 2, 3, 4, 5, 6. Okay. This is number systems. Now, what is the remainder when 85 into 87 is divided by 100? When you see the question, see the attack point. Our attack point here is 100. Okay. And now, a common principle. How do you divide any number? Normally, suppose 2 into 6 is there, divided by 2 into 4. What you do? You cancel out the common parts first and proceed forward. This is a principle from which we have been seeing from our first class. This question is nothing more than that. If you see, he asks what is this number divided by 100. Now, how can 100 be divided, break down into? It is 4 into 25. Okay. 4 is nothing but, do prime factorization, 2 square into 5 square. So all you need to find the answer of this question is just find 2 2's and 2 5's somewhere. Now at the first glance itself, this number is divisible by 5. So it is 5 into some x. Need not even care what that number is. So 1 5 is gone. Next, one more 5 from here. 5 into some y. Need not even care about y. So 2 5's are gone. Next, we need 2 squares. 2 2's, which is, this is a multiple of 4. So 4 into some z. So 2 square and these two gone. So since everything got cancelled, the remainder is 0, which is option A. Such an easy question. What are the principles involved? Nothing but basic cancellation, which we have to been doing from our childhood onwards. Now, next one. Next number systems question is, yes, 8. 7. Now, what is the unit digit in the expansion of 57242 into 97531? Pause here a bit and think about the question. He is asking us unit digits, and unit digit is dependent on the unit digit. Okay. So we got it is something to the 2 to the power of, based on this power this is present. Now what most of us do in a conventional way, you might have seen this many way. Since 2 has a cyclicity of 4, they divide this product by 4. Very good. They do this product and divide by 4 and see whether it is a product of 4 or not. If you are a student, if you are my student, I would have already discussed in class the concept of negative remainder. Just a brief introduction. Remainder is always distance from the nearest multiple. Okay. Suppose take the example of 9. 9 by 2 is remainder of 1. 1 denotes here the distance between the nearest multiple. Suppose 8, 1, 2, 3, so on so forth until 8. 8 is a multiple of 2. Remainder shows us that our 9 is one distance away from 8. This is 1. And since I told you remainder is a distance, when you can measure this distance, you can measure the distance from the next multiple too. For example, what is the next multiple of 8? It is 10. Okay. And you can measure this distance too. This distance is called negative remainder. This is positive remainder and this is negative remainder. We have discussed in class many times. Now just observe this. 9 is 1 apart from a multiple of 4. 7 is also 1 apart from multiple of 4. 5 same case, 3 same case, and 1. So what does this finally lead to? 9 gives you a positive remainder when divided by 4. 7 gives you a negative remainder. Positive remainder 5 and 3 negative remainder into 1. This is nothing but the remainder is 1. 2 to the power of 1 gives you 2. So this is the answer. See, this is just a multiplication of 1s, nothing more, nothing complex, if you know that the concept of negative remainder. In the conventional way, you need to multiply all this and divide by 4. But here, negative remainder concept, it is just hardly a 30-second thought in your brain. Now, next one. Next question is 14. Yes. Now, this talks you about there are 5 positive integers P, Q, R, S, T. Okay, this is our attack point. Are even and 2 of them are odd. Okay, good. Not necessarily in any order. Consider the following. Normally, what people do is they take some examples, some random examples, and try to force fit this into the equation and see it is even or odd. They may get it sometimes, but always they may get it here once, right? They may get it right once, but always following equations is a better way to solve such type of problems. Now, and what is he is asking, this is definitely even. So this is one more attacking point. Whenever anything is definite, all we need to do is we need to prove it wrong. For this proving, even one instance of this being wrong cancels this. In the same way, this too. So all we look for in such instances is, in such cases is instances where this is wrong. Now, since 2 are odd, you take any number, always, what are the rules? Odd plus even is odd, even plus even is even, and odd plus odd is equals to even. I will give you a short visual method to represent this, no need to by heart. Always consider odd as having a projection and even as having a flat tip. Okay. Now, odd plus even, when you consider these, you will get a projection at the top. So, this is odd. Even plus even, 2 squares, you will always get a flat top. So, it is even. And odd plus odd, one projection and another projection will give you an even surface. So, this is a good visual representation for you to follow. Now, since any two of them are odd, consider S and T, and the rules of odd and even for both addition and subtraction are same. So, S and T is always even and these are always even because remaining 3. So, in all cases this will be even. So, statement 1 is correct. And 2, what did I tell you? Since again he has used the word definitely, we need to prove, we need to look out for an instance where this will be wrong. Now, is definitely odd, that means we need to look out when this will be even. Now, let us take any one of the P and R as odd. Okay. Odd multiplied by 2, anything multiplied by an even number is an even number. So, this is even, Q is already even, R is odd, but multiplied to it becomes even, and remaining all are even and even. So, we are getting a case where this is not odd and even all evens is even. So, instead of force fitting each instances 1 or 2 or some other digits, just go by equations, go by principles, go by basic principles, it becomes much more easier. Now, this is only option 1. Next, 15. Now, pause a bit and read the question properly. Consider the following with respect of prime number and composite number. So, our attack points are prime number P and composite number C. Now, what is the result in the questions? He is asking, can these be even? Can these be odd? Can these be odd? So, we need to further look into prime and composites and see how many are odd or how many are even. Now, explain the basic concept here. We have primes. What does prime consist of? Both even and odd numbers. As you know, 2 is a prime number and all remaining primes are odd. So, prime has both even and odd numbers. In the same way, composites too. Composite number, we have 4, 6 example which are even, and even odd composites like 9, 15, they are odd. So, now let us apply this basic principle here. P plus C can be even. For this to be even, if these are even, you need not see for each specific instance. You can go by the principle itself. P plus C. For this to be even, P has to be even and C has to be even. Now, are there even primes? Yes, 2 is an even prime. Are there even composites? Yes, 4, 6 and all are even composites only. So, this can be an even. and P minus C. Same rule applies here. So, this is a true statement. This can be even. Next, 2P plus C can be odd. For odd to exist, one case. Anyhow, this is multiplied by 2. When anything is multiplied by 2, this is obviously even. And the result being odd depends on the composite number being even or odd. Do we have odd composites? Yes, we have odd composites, 9, 15 and all. So, this can be odd. So, 2P plus C can be odd. Even one existence of one case of it being odd proves our case. So, this is true. And PC can be odd. For a multiplication to be odd, both the products have to be odd. Both the constituents have to be odd. So, do we get an odd prime? Yes, we have odd primes 3, 5, 6 and all. Do we have odd composites? Yes, 9 and 15. So, this can be odd too. So, instead of force fitting and thinking of answers which can be forcefully fitted into this, think from the basic principles itself. So, since all three statements are correct, the answer is 1, 2 and 3. No. Next one is 17. No. You remember my point of looking for patterns. This pattern especially. 1001. It has been repeated even in this paper 2 or 3 times. We'll reach that when we see that. This is nothing but 13 into 7 into 11. Now, this is a form of divisibility rule. You know how divisibility works? The basic, no, you might have heard that, suppose for example, the basic divisibility rule of 2 is the ones digit should be even. Ever questioned how that divisibility rule came? Let me give you. Any number x, y, z in decimal form can be represented as, this is 10 to the power of 0. Since this is a decimal system, 10 to the power of 1 and 10 to the power of 2, which means 100 into x plus 10 into y plus 1 into z. Now, divide this by 2. Since 2 is a factor of 10 or 10 being a multiple of 2, no matter what we do, here remainder is 0. And same here, 100 being a multiple of 2, here the remainder is 0. So, the remainder obviously depends on z, the unit digit z. That is why the divisibility rule for 2 is, see the component of unit digit, if it is even, then it is divisible. In the same way, for 1001, it is of the form 10n plus 1, where here n is 3. For all questions of this type, you should make a group of n digits. For example, you get a number A, B, C, D, E, F and G. If you get something like this, if it is 10 power 1, make n numbers. For example, 1000 is 10 to the power of 3 plus 1. So, make 3 blocks. EFG is one block, BCD is one block and A is another block. And alternate between positive and negative signs. Okay? Alternate between positive and negative signs and do this. Now, if this resultant is divisible if after doing this, for example, what does this account to? EFG plus A minus of B, C, D. If the result is divisible, then the number is divisible. For example, take for 13. If this result is divisible by 13, then this whole number is divisible by 13. Same case for 11 and same case for 7 too. Okay, this is 10n plus 1 rule. Now, observe here. Since we are taking 3 and 3 common and we are negating it, all 6 digits, the result of all 6 digits will be, if these are common, what we will do? Suppose A are that. Okay. Now, what is the result of this? We divide into blocks of 3. This is plus, this is minus. So, obviously, this becomes 0. And this falls under 10n plus 1 rule. 10n plus 1 rule gives you, for n is equals to 3, we will get 1001. Okay. This is the pattern. You will find that this 1001 repeating again in the same question paper itself. So, always be very, very careful of this. Remember this. And see, all are prime numbers too. So, it is important from the point of pattern and from the point of prime numbers also. Now, since he has said that this block is being repeated again and it looks like all 6, if you minus all this, you will get 0 or multiples of any of this. So, since you are always getting 0 here, this will always be divisible by 7, 11 and 13. So, if you just know that 1001 equal to 13 into 7 into 11 and the divisibility rule of 10n plus 1, this is done. So, 7, 11 and 13. – 25. Next number system is 25th. Now, another important easy question. What does he ask? Let x be a positive integer such that 7x plus 96 is divisible by x. How many values of x are possible? Now, 7x plus 96 divided by x. This can also be written as 7x by x plus 96 by x. Since this is already divisible, we need to concentrate on 96 by x. For this to be divisible, x has to be a factor of 96. Suppose, take 8. You can divide 8 by 1. 8 is divisible by 1. Next, 8 is divisible by 2. 8 is divisible by 4 and 8 is divisible by 8. These all are nothing but factors of 8. So, indirectly what he is asking is factors of 96. So, number of factors of 96 is equals to, what is the easiest way to do this? Prime factorization form. Four into 24, and this can be further into just keep on dividing this. 4 into 6, this 6 can be 2 into 3. So, 2 to the power of 5 into 3, and number of factors is x plus 1 if a to the power of x into b to the power of y is the prime factorization form, number of factors are x plus 1 into y plus 1. Applying this, 5 plus 1 into 1 plus 1, because 3 means 3 to the power of 1, which is 12. Simple. What is there? What is the complexity in this? Just you know that formula for number of factors, and this is done. In the same case, last case, you know 1001, you know 10 to the power of n plus 1 rule, you see the pattern there, you get the answer. Next is 27. No, told you that 1001 pattern is going to repeat again, 10n plus 1, sorry. Or 1001 is equals to 13 into 7 into 11. See here, same. For this, the divisibility rule is divide a number into blocks of 3 and attribute alternate signs starting from the right. Now, what has given you a number n has been formed by writing 9 for 999 times. 9, 9, 9, so on 999 times. What did I tell you? Since we are dealing with threes, a block of 6 easily gets nullified. What does this mean? Nullified means it contributes a 0 to the remainder. Okay. Now, what do? Divide all these 99s into blocks of 6, because each block contributes 0, and then see how many are left out. You will get a remainder of 3. So, what he asks us to find is the remainder of 0 plus 0 plus 0, so on and so forth, 96 nines. Because a block of 6 adds nothing to an remainder, so this all becomes 0. What he is asking is this, and you can easily calculate. $999 divided by 13. Remainder of so the remainder is 11. Not much complex. It may seem complex at first. Oh, 99 nines are there. How do we do it? But if you know the rule that 1001 pattern, I told you at the first of the start of the session itself, pattern finding is important. Pattern finding is important. You get that 1001 is equals to 13 into 7 into 11, and see this. After this, apply that. If 3 are same, a block of 6 adds 0 to the remainder, and you will end up here directly. Hardly a 1-minute question this. Now, see how this may seem difficult at first, but by knowing the finding out the pattern and by applying, even after you know the pattern, you need a bit of application here. Application is combining 3 digits and 3 digits. So, a 6-digit block contributes 0 is your application here. Once you get that, this is hardly a difficult problem. No. Oh, we are almost at the end of number system topics. You see, not even until now we get a difficult questions where I needed to explain more. I'm taking this much time because I'm explaining the concepts a bit more. But all number system problems, especially in 2023, same, they follow the same pattern. Attack point, you identify the pattern and the answer is there right in front of you. Now, the next one is, next number systems question is, This is 27. Okay. Next one is 28. Select. Clean. Same again. A pattern based one. Each digit, first pause and study. Each digit of a 9-digit number is 1. Okay. It is multiplied by itself. Then what is the sum of digits of the resulting number? Now, the point I made you before about patterns, once again. Here he is asking a 9-digit number of ones. So it might be difficult for you, but start from the first. Since he is saying all ones, our attack point is a number consisting of all ones. Now take 11. 11 into 11, 121, right? Next, 311 into 311, 1, 2, 3, 2, 1. You find a pattern here. It is the number of ones. The result is nothing but how many ones are there? How many ones are there in the product? Each 2 ones are there. For result, start writing natural numbers until the number of ones. Here 2 ones are there, we wrote until 2, and then decrease. It is 1. Now here 3 ones are there, we wrote until 3, and then step by step decrease. So on and so forth. This is the pattern. Now he is asking us for 9 digit. So 9 ones are there into 111 9 times. So what will be based on this pattern? Until 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then reduce 8, 7, 6, 5. 5, 4, 3, 2, 1. Now, how do you get the digits? Don't just go on adding. It's not an efficient method. We know that the sum of first n digits is n into n plus 1 by 2. Okay. Now, here n is 9. So, 9 into 10 by 2, 45. So, until here the sum of digits is 45. And what is this side lacking? It is lacking only 9. It is nothing but 45 minus 9, which is 45 plus 45 minus 9 is 36. You add, you will get 81. Simple. Based on same again. You find the pattern, answer is right in front of you. So, you see how this complicates even training students too, because previously if you teach formulas or if you are thorough with the subject, you would have gone. But here, even if you know all the formulas, if you don't find the patterns, it means nothing here. So, I told you the first point there, UPSC wants to think. If you are unable to see the pattern here, of course 9 nines is difficult, but pattern with 2 ones is easy enough. Every one of us knows the 11 square, 121. So formulas, they don't work in, especially in UPSC 2023. What it needs is you to think and find the pattern. In the same way, let's see one more. Next is 49. Next, number systems. Previously we used to get direct calendar questions. Now see, even this has an application of both calendars and number systems. Now we all know that calendar problems depend on odd days, and odd days depend on a cyclicity of 7. Now what all we need to do is find the number of odd days in this digit and then apply here. Now 10 to the power of 10 by 7. Since 10 is more, we can do basic division. So the remainder here is 3. 7 1 10 and 3 is remains. 3 to the power of 10 by 7 again. Now since this is less, you always have this thing. Always your remainder will be less than your divisor. But here in this case, our divisor is 7, our dividend is 3 only. So just take it to the next power such that it is just above 7, our divisor. It can be written as 3 square to the power of 10 by 2 using index power formula by 7, which gives you again 3 square is 9, 9 to the power of 5 by 7, and again same 2 is the remainder here, 2 to the power of 5, which is 32 by 7, which is 4 as remainder. So there are 4 odd days. Now if it is Sunday, Monday, Tuesday, Wednesday, Thursday, 4 days. So Thursday is the answer. Same, you might have got frightened by seeing this, but apply the basic cyclicity of 7 and remainder theorem. Nothing much more complex, just knowing the pattern of division and remainder, and there you have the answer. Next, 50. This is an interesting question. Now see the attack points here. There are 3 traffic signals. Each signal changes color from green to red and then from red to green. Okay, so it has a cycle of 2. I am writing here attack points. It has a cycle of 2. Good. Next, the first signal takes 25 seconds, the second signal takes 39 seconds, and the third signal takes 60 seconds. Okay, to change the color from green to red. Okay, the durations for the green and red colors and green and the red colors are same. Okay, from green to red and red to green, the duration is same. Now at 2 p.m. they together turn green. At what time will they change to green next simultaneously? So what he is asking is, those signals change from at 2 p.m. they were green. After this they turn into red and then they turn into green again. He said they occur at the same time at 2 p.m. What is the next time that they are going to occur simultaneously? Now this is a basic problem of LCM. The longest time that they need to simultaneously shift is nothing but LCM of 39, 25 and 60. So LCM of 39, 25 and 60. Now you might start from finding LCM, but if you are my student, you know the jugaad way I told you. Always consider the biggest number as LCM, 60. and look out for a pair of a common number and a coprime. As we have discussed many times in class, here it is 20 into 3, here it is 13 into 3. 3 is common and 20 and 13 are coprime pair. So multiply whatever you don't have. Here we have 20 into 3, so this is 13. And next, move on to the next. This is 25 here, this is 60 into 13. What we don't have? This is 5 into 5. Here we have 12 into 5. Again, 5 is common and 12 and 5 form a coprime pair. So we don't have 1 5, we have only 1 5, there are 2 5s here. So multiply by 5 again. So this is 60 into 65. Since it is seconds, need not even go further, because 60 seconds makes 1 minute. So for one change green to red, it takes 65 minutes or 1 hour 5 minutes if you convert into minutes. And from here to here, since he has already given that it is same, it will also take 65 minutes or 1 hour 5 minutes. In total 2 hours 10 minutes. So at 2 it is same after 2 hours 10 minutes, which is 4 hours 10 minutes. This Jugaad way actually helps you make your calculation easier. So remind this. And for those who are not aware of this, it is like this. Suppose you have a numbers A and B. Just explaining the basics, you can learn further. You should always consider the highest number as LCM, and then you should divide your LCM and next number in such a pair that one number will be common in both, and second number will be a pair. What pair? Coprime pair. B and C should be coprime. In such a case, your LCM is nothing but the thing you don't have here. What you don't have? You have already A and C, you don't have B. Sorry, B is there. Suppose take this as capital B. This is small b. This is the easiest way to find LCM instead of that prime factorization and long division method. Once you get hold of this, calculation becomes much more easier. Next problem is 74. One more beautiful problem. This is just instantaneous if you know what to look out for. Now, he is asking what is the remainder of 2 to the power of 192 divided by 6. Okay, this is a special pair. 4 and 6 is always a special pair. No matter whatever the multiple of 6 or power of 4, or no matter whatever the multiple of 4, if it is divided by 6, the remainder is always 4. Seems unbelievable? Look, 4 divided by 6, remainder 4. Next, 4 to the power 2 divided by 6. not multiples, powers. Any power of 4 when divided by 6 gives you remainder of 4. 4 this is 16, 4 square is 16, 4 cube 64, remainder 4. So, this is always 4. Now see, you see 2 here and an even power 2. So, convert into 4. 2 to the power of 192 divided by 2. So, by 6. No matter the power, as we have seen in this case, the remainder will always be 4. Hardly 30 seconds. Let's see if there are still more number system problems. No, the 2-digit. Okay, this is the end. So, what did you get from this analysis? (2023) number systems. First, like all people have said, it is not difficult. And 2, what makes it easy? Always the tried and tested method, attack points, and 3, patterns. All are hardly even less than a minute problems, and all are solvable if you know where to attack and basics itself. Remainder theorem, and next LCM, calculating LCM. Normally in that LCM problem, people take much time calculating that LCM itself. There will be some problems where you need to spend more time. There will be some problems where you can just flush out the answer. Don't waste energy in your calculations, energy or time in calculations, because it will add up to the in solving difficult problems. It will make it much more difficult. So, get your calculations in order. So, at least we solved at least more than 10 to 13 number of questions. 13 into 2.5. You are already near the halfway mark, and these are somewhere near the halfway mark, and these are less than 1 minute problems. So, in 10 minutes of your 2023 paper, if you are comfortable with number systems, you would have already crossed the halfway mark. The whole exam is for 2 hours. You see what number systems, being competent in number systems gives you. It will allow you, like no other questions on no other topic, it will allow you to easily scale this, and there are nothing much apart from that. There are factors, there are LCM, odd even, prime, remainder theorem, that's it. So, I know there is a fear in students regarding number systems. Don't fear number systems. Number systems makes things much more easier, provided you find the pattern and you know the attack points where to attack. We'll conclude here, and in the next session we'll take up one more topic of 2023 in the same way, attack points, and all with the same efficiency. I'll give you not just the solutions, the most efficient ways possible to solve a problem. See you soon.